process, since we're trying to see how much energy is needed to heat up the eggs from refrigerator temperature to room temperature, we're going to use the equation Q equals mc delta T. For the mass, one egg weighs 60 grams, so in kilograms that's 0.06, and I multiplied it by 2 because we're putting 2 eggs into the batter, so in total we get 0.12 kilograms. So we're going to write down our knowns. So we know that the heat transfer coefficient is 721 joules per kilogram degrees Celsius for air at 25 degrees Celsius, which is room temperature. And then the temperature of the refrigerated egg is 4.44 degrees Celsius, and then its final temperature is 25 degrees Celsius. Since we know that the butter is going from a solid to a liquid, we have to use the phase change equation, which is Q equals plus or minus m times L. So the m here is our mass, and then the L here is our latent heat. Specifically, we're using the latent heat of fusion, so it's L subscript F. And we know that our Q in the end is going to be positive because we're adding energy into the system. So the mass of our butter is 227 grams, which is 0.227 kilograms, and that's for 1 cup of butter, which the recipe calls for. And then I looked it up and it said that the latent heat of fusion for butter is 60 kilojoules per kilogram. In addition to accounting for the heat energy needed for the phase change, we also need to account for the change in temperature. So we're using the equation Q equals mc delta T, where our m is 0.227 kilograms, our specific heat capacity for the butter is 2.04 kilojoules per kilogram degrees Celsius, our initial temperature is 1.67 degrees Celsius, and our final temperature is 28.33 degrees Celsius. So for Q equals mc delta T, we know that our C is equal to 2 joules per gram degrees Celsius. For a brownie batter and a blondie batter is pretty much the same, so I'm assuming that they're similar enough. And then the mass for our entire batter is 1,206 grams, which is 1.206 kilograms. And then our first temperature is 25 degrees Celsius. And then our final temperature, which is the internal temperature of the brownies once they're done baking, is 73.89 degrees Celsius. Because we're changing phases from the liquid batter to the solid product, we have to use the equation Q equals plus or minus m times L. So our m is about 1,206 grams, but I looked up and I couldn't find the latent heat of fusion for brownie batter or anything similar to that, so we cannot calculate this one.